Welcome to today's stand-up meeting at Open Research Institute. We're going to talk about what we did over the past week, what we have planned over the next week, and if we need any resources for what we're doing, and if we've experienced any roadblocks. We've had some significant steps forward and some progress over the past week. So I am going to pass it to Évariste to talk about what's been going on. The floor is yours, Évariste.
Okay, thank you. Can you hear me?
Yes.
Yes, okay. So today was today or yesterday, can't remember. The successful of the receiving the DVB encoder. So Shuto has done some modification this week and give me the design, and I included in the firmware of the Pluto. And right now we don't have any error, and we can decode all the transport streams. So we have a proof of concept, which is a validation of all the components in the FPGA and running on the Pluto. So it's very good news. I need to inspect why I have some problem on my design. So, but it's just some comparison and try to understand what's happening before. Then we need to, as we are in a debug step, we have to set all the parameters back. And yeah, but it's very happy that it works right now. And it works even at 15 megasample. So very quick and without CPU, of course, because all is done on the FPGA. Back to you.
Thank you very much. Yes, this is extremely good news, and we will work hard to make sure that that news is publicized and explained over the next week. So thank you so much. This is a lot of wonderful and appreciated work. Please let me know if you need any additional resources or if you have any roadblocks that you don't know how to handle on your own. And that's my job. That's what I'm here to help with. Okay, so Leonard, you have the floor.
Sorry about that, was on mute. Mainly, I haven't really made a whole lot of progress other than getting GNU Radio up and running on both the Windows platform and then also with WSL. So I was able to generate the artifacts in WSL and also in the Windows platform using the GUI. Basically, you could only, you set it up once and then you generate, and that's one data set. With Andre, we went through using PyCharm as the IDE and /debugger, and we were able to get it to run through there. There was an issue where if the couple of the Py files, run.py, and also the other one main script that it generates the diagram with, if they have both carriage returns and new lines, then it'll kind of come up with a failure, or it won't go through the run. So if you save the file as like in Notepad++, you can save it as Unix or Mac or whatever, and then it'll only have the line return without the carriage return. And then that'll go through and generate the whole script. I also was able to get GNU Radio to come up as a GUI in using WSL2 using, I believe it was Xming, just a X11 server. And I tried it with Xwin server. For some reason that didn't work, but Xming did work. Something that makes me a little bit nervous there is that they want you to open up, ports and IP addresses and kind of to the public. So I need to kind of go down there. I just don't want to. I want to have those ports locked down to make sure hacking attempts don't come in on those ports. The other thing I was doing was kind of creating a, let's say, a Vivado IP library where the core itself is you can just have it associated with an IP repository, like a library, like just like the Vivado standard stuff is, but it's a user-based version, and then you can just select it and drag it down and put it into a block diagram. Not associated with a DVB, repository the way it is now. So I've been kind of successful with that. There's a couple of issues with the tickle where it's generating the stuff in the wrong directory, but for the most part, that's in progress and pseudo kind of working depending on how you look at it. Anyways, that's all I've done really.
Oh, thank you. So you're using Vivado IP Packager in order to attempt to get our work into the IP catalog? Is that the goal?
Yeah. So you have a user IP catalog. I've segmented out the kind of the source files and used IP Packager to do that, and then generate a tickle file that will rebuild, the project and all that. So so that when we check it into Git, you don't have to check in all the artifacts and stuff like that.
Oh, thank you. That's very useful and appreciated work. All right. Do you need anything, or do you have any roadblocks that you're not capable of, demolishing yourself?
No, I mean, I'm plugging along slowly but surely. The main issue is you're dealing with a couple different levels of open source stuff has various levels of documentation, and the analog devices is not really in sync with GNU radio. So I've been also trying to get the Pluto to work with GNU radio. Been having a little bit of problem there, and certainly in the Windows-based version, but looks like with Xming it does appear as a sink and a source correctly though.
Very good.
So that's the Xming is basically Windows WSL2 with the X11 server with Xming as the capturing the display basically.
Oh, sounds good. All right. So thank you. That's excellent progress, and looking forward to seeing this become part of the catalog. That would be a huge step forward. Sawato, hello, you have the floor. Okay, I don't hear any audio from Sawato. Go ahead, Paul, you have the floor, and we'll come back to Sawato.
Okay, we do have some progress to report this week. With your help and encouragement, Michelle, we have installed the Deck Tech boards into computers in the remote lab, and are able to actually send and receive DVB S2 video using MPEG transport streams on those boards. These are professional level laboratory boards, really not intended for use by consumers or anything like that, for testing. And it's very timely that we were able to do that in time to validate DVB-S2 streams that are being generated. There's the DTA 2115B is a board, PCIe board that requires 1x PCIe lane, and it's able to transmit virtually anything up to like 72 megahertz of bandwidth, and has specific support for many of the broadcast waveforms, including DVB-S2 and S2X. That board is installed in Aperture, which is the Windows machine we've had since before the main machine was installed in the remote lab. And the other board is a DTA 2132, which is a receiver board specialized for DVB-S2 and S2X. And it's able to handle full rate data streams up to like 70 megabits or megasymbols. Maybe not quite that high, but plenty high for us, with almost no CPU load. So it can do everything we're going to need for that. The software that comes with this is Windows software, and the transmitter is called Stream Express, and it can transmit from a file, which is handy for testing. And Stream Expert, which is the receiver, and Stream Analyzer. Both of these things are intended for video broadcast applications primarily, and they have some restrictions on what they can do. They really only understand MPEG transport streams. In addition to these very fancy user interface programs that are nice to work with, there's a software development toolkit which works on Linux as well as on Windows. Excuse me. And we have not yet begun to explore these, but hopefully they'll be able to use these with GSE and get a little closer to our exact needs. The original plan was to install the receiver board, the DTA 2132, and its corresponding software, Stream Expert, in Chonk, in the Windows VM there, which we call Chonk Win 10. And that was done, and it worked, but we couldn't tell that it was working because we were a little confused about some things. Thought it might be an issue of working in a VM. So we pulled that board out of the VM and put it in a separate standalone machine loaned by Michelle called Hello Kitai. And that machine behaved exactly the same way as the VM did. So apparently that theory was wrong. The actual problem we were having was debugged with great assistance from Everest, and mainly from Ron, W6RZ, on Slack a few nights ago. And so that I was leaving it in Hello Kitai until we were able to get that problem solved, because we might need to go for tech support. And if you say you're in a VM, everybody can say, well, okay, it's a VM, so you better get out of there before we try to give you any tech support. That may no longer be an issue since it's working. So it might transfer that back into Chonk. I'm not sure what the plan for that is going to be. You have to give it some thought. And there are some additional tests that need to be done. So we're now in a position to test DVB-S2 waveforms, transmit or receive against this high-end commercial hardware that can be remoted or done locally here, depending on what the requirement is. The Hello Kitai is not currently remotable from the remote lab, but that's easy to set up if that's what we want to do. I don't have any blockers at the moment on the remote lab, as far as I know. Back to you.
Thank you. Yeah, it's good progress, and excellent to see. Like Paul explained, having sort of a commercial known good or golden hardware to both handle receive and transmit gives us a lot of flexibility in terms of verification and validation, which is very important to us on the project. Okay, and we have Swato here. So please, you have the floor. Go ahead.
Can you hear me now?
Yes, I can hear you.
Yeah, sorry, never mind. So Evariste and I, we were going around the loop trying to get the thing working. So we found out that there was some integration issues and some adjustments we had to do. But Evariste, I think, yes, not yesterday, the day before, I think he tried with smaller chunks, smaller transfers, and that eventually worked. So I have some changes I did to the repository to that I want to push into the main branch. I basically removed the polyphase filter from the encoder. I plan to have sort of a test of both together. But because I think the polyphase filter, the one we have is big, as in it uses a lot of resources. So the filter might need to be independently adjusted. But that's just minor. That's, you know, basically pushing things that we did in between to the repository. And that's about it, really. I think Evariste is the person who has the setup. I think he might be able to comment more.
Okay, yeah, go ahead, Evariste, if you have some comments about the filter.
Yeah. So the polyphase filter is very consuming a lot of area in the FPGA, and as we discussed with Ron, well, I usually use a FEAR filter, which is very lighter, and it's already have 40 or 45 dB without any shoulder, so it's good enough compared to the polyphase filter. And well, for the analog device design, there is on the AD9033, there is already a FEAR filter inside. Here we use the FEAR filter in the FPGA, which is more portable, which means that we can integrate it in the IP, which could be very good solution to have an IP, well, for user perspective, as Leonard say, integrate directly on Vivado, so it could be used the FEAR filter from that. The last thing is, the design from Suato is working, but I have still some locking and unlocking, and I try to send little block instead of big block of DMA, and try also to set the size of a BB frame or a multiple of BB frame, which could maybe corrupt the FPGA design. Well, that's some investigation we have to do, but we have the main proof of concept, so it's very good. And I just wait for Suato to give me his design to compare with mine, because I don't understand what the problem, or maybe because I think, Suato, you solved some timing issue on the original design of the analog device, which could maybe explain that. But right now, I don't understand why my design is not working properly.
Mm-hmm. Yeah, I can. Yeah, the timing issues were on the receive path. It's I'm just thinking how to best share that, as in I can compress the design I have and send, because it's changes on the analog devices stuff. It's just that not the DAC, that ADC DMA, and there is some constraints issues. So what I did was change the ADC DMA to be single clock instead of dual clock, and change the clock in the, you can change in some other places, like you don't have to add FIFOs, you just tell the interconnect that channel needs to use a different clock.
Okay. So the same as we did with the TX path, right?
The TX is slightly different, but the TX is more, it's more complicated, as in, yes, make the DMA part a single clock.
Yeah.
In the TX, we had to add the FIFO. In the RX, we just need to, in the AXI source and destination stuff, we just need to change the clock that generates that. We don't need to add a FIFO. Yeah.
Okay. So just back, and I will try to analyze it. It's the easiest way right now, I think.
Sorry, say that again.
Yeah, just make a tar of your project, and I could import on Vivado, and it would be perfect.
I'll do in a few moments. Yeah.
Okay, thank you.
Yeah, very good. Thank you so much. It's deeply appreciated, and I'll do all that I can to make sure that everybody hears about it and that we get lots of people knowing about it so that they can use it. And we'll go from there. I'm really looking forward to the next time we get to demonstrate over the air, because it sounds like we will have something that's working over the air. Okay, so we have some people here that might have some comments or questions. Go ahead, Douglas, you have the floor.
No comments or questions at this time.
All right, thank you so much. All right, and Rick, you have the floor.
I don't have anything particular to say. I'm just very interested in the progress. It sounds great.
Oh, thank you. Yeah, the feedback really helps. It's sort of like the only pay you get, right? Is the appreciation and feedback, comment and critique, and eventual use. So yeah, we're targeting having this working over the air in a demo in August at DEF CON, and we will keep working on that. I have a brief report, been continuing with MATLAB HDL Coder, and there is a webinar coming up tomorrow from MATLAB that talks about how to use MATLAB products for space communications. So I will write a memo like I've been doing for the other webinars, and I'll post it on Slack and share it on the list. And we are moving towards an IEEE co-hosted event in May, or very early May, on the 4th, to talk about the forward error correction used on the M17 protocol, which is our uplink that will eventually feed the things that are encoded on the downlink that we're discussing today. And that presentation has the support of Fred Harris and a couple of other folks that have contributed towards a MATLAB script of M17. So this MATLAB work will then be fed into HDL Coder, and then it will eventually be tried out as HDL in remote labs with the goal of incorporating it into the IP. This tries out several things, tries out the tool flow progress from MATLAB to HDL Coder to FPGA bitstream. And we are also looking at and have documented some discussions and some work, some action items to try to, what we're doing is taking the VHF, UHF, relatively narrow band protocol, M17 protocol, and what do we need to do in order to make it a wider band or higher bit rate uplink protocol for our particular transponder. So that's the things that have been going on over the past week, and the plans will continue over the next week. So progress has been good on that front too. All right, thank you, everybody. I'll open the floor for any last comments or requests, or yeah, anything that you need. Okay, well, we'll see you next week for this particular meeting. There's other meetings coming up, so keep an eye on the schedule. Thank you so much for being here today. Your participation and your interest is deeply appreciated. All right, see you soon.